Alright, so in this video we're going to talk about something, hopefully it's a little bit familiar to you, but the idea of parallel versus perpendicular lines and what they are and how to find them. So if you look at the pictures I've drawn here, the one on the left is a set of parallel lines, and usually in pictures, if they're parallel, I'm not going to say always because sometimes people leave them off, but you should see some kind of little triangular looking, I don't know what to call it, caret like on the keyboard sign. So that's your mark for parallel. So if you don't see it and they tell you it's parallel, it's cool. But if they don't say two lines are parallel and they don't mark it that way, just be cautious at calling them parallel. And then on the right hand side, you have perpendicular, and this little right angle symbol, the box here, is your perpendicular symbol, telling you that these two lines cross at right angles. Alright, so here's your parallel line definition. Two lines that never intersect or cross. They have the same slope and different y-intercepts. So again, there's your symbols. This is your symbol in just more writing notation out for like naming lines. So you can say line AB is parallel with the two L or two ones, whatever you want to call it, symbol. And then down here, you've got same slopes, remember. So if you've got two equations and you want to know if they're parallel, you're looking at the slopes, which I've underlined. And in this case, they're both 2's, which means they're the same. So those two would be examples of parallel lines. As far as perpendicular, on the other end of the spectrum, you've got two lines that intersect at right angles specifically. You can have two lines that intersect all day long, but there is one special case when they're perpendicular that called parallel. So when they are intersecting, be careful if you don't see the little symbol that I showed you for perpendicular, because they're probably not perpendicular. Alright, and then they have opposite reciprocal slopes, and what I mean by opposite reciprocal is the opposite sign, and a reciprocal fraction, which means flip the fraction. So down here in my example, I've underlined the two slopes. One of them is a positive 2, the other's a negative 1/2. Well, you have one positive, one negative. That's the opposite sign that we're talking about. So when I say opposite, I want opposite signs. And then reciprocal, well, 2 over 1 up top, you can put anything over 1, so this is like 2 over 1. The reciprocal of that is 1 over 2. So 2 and negative 1/2 are opposite reciprocals of each other. That's why this is a perpendicular set of lines. Alright, so if you ever see something like this, the instructions will probably be like, identify these as parallel or perpendicular or neither, since that is a case as well. So we want to go through and see what kind of lines we have here without having to graph these, because we could graph them. They're not bad lines to graph, but who wants to waste that time? Hopefully not you. So in the first one, remember what we care about is slope. So the first slope up top is 2. The other slope down bottom, let's call this M1, and this slope 2, M sub 2, equals negative 1/2. Well, then you got to ask yourself, what kind of relationship do these two numbers have? We know if they're the same exact number, they're parallel. Well, that's not going to be the case, because 2 and negative 1/2 are not the same number. Then you have to ask yourself, are they opposite reciprocals, to see if they're perpendicular? Well, one's positive, one negative, so they're good, opposites. And then reciprocals, the first one's 2 over 1, the next one's 1 over 2. So these are opposite reciprocals of each other. So this would be a perpendicular set of lines. And this upside down capital T is the symbol for perpendicular. So I'm just going to shorthand it here. Alright, this example, the first slope is 4. The second slope is 4. So again, go through your criteria. Are they the same number? Well, yeah, they are in this case. So this means that they are the same slope. So we have parallel lines. And the two L's are parallel, like I said before. And then on this one, the first slope is 3. The second slope is negative 3. So go through your criteria. Are they the same? No. Are they opposite reciprocals? Well, some of you are going to fall into that trap. Hopefully not, though, if you do this enough. They are opposites, I agree, but they are not reciprocals of each other. So this is the case when they are neither. So you have to be careful. Don't fall in that trap. Alright, on this, same idea, parallel, perpendicular, or neither, but they have not explicitly given these to you in a form that is conducive to pulling off the slope yet. So you're going to have to rearrange these. And in another video, I showed you what I call the slope trick, so you might want to go watch the slope trick in order to understand this a little better and get these answers faster. But since we don't know the trick right now, I'm going to show you how to rearrange again. So we're going to rearrange this first equation, 4y, so it's in slope intercept, so I need to move the x. So y equals negative x plus 5. Then we need to rearrange the second equation for y. Minus x, oops, sorry. So y equals negative x minus 10. And then go look at the slopes. Well, the slope here is m equals negative 1. Let's call that m1 again. Slope down here is negative 1, so these would be parallel. Alright, over here we need to rearrange them again. So we've got x plus y equals 5, which we just rearranged over here. I'm not going to do it again. So we've got y equals negative x plus 5. And then we'll rearrange this other one since it's a new equation. Minus x, negative y equals negative x plus 5. And again, you can't keep y negative, so we need to divide by negative 1 through the whole equation. So y positive equals a positive x minus 5. So if you look at your slope here, we already said this slope, we'll call it m1 again, is negative 1. Down here, m equals positive 1. So are they the same? No, so it's not parallel again. Are they opposite reciprocals? No, don't fall in the trap. They're opposites, but they're, well, I guess technically these could be reciprocals, 1 over 1, 1 over 1, so we'll go with it, perpendicular. So you have a negative 1 over 1. The reciprocal of 1 over 1 is 1 over 1, so kind of a trick question here. So these are reciprocals of each other, and they're opposite, so it's perpendicular. All right, here's your practice questions. When you're ready, pause the video. If you need to go back, watch the video again. I've put all of these so that you're going to have to rearrange, just so you're doing some extra practice at simplifying and solving for one variable. And again, if you want to go watch the slope trick video real quick to find the slope trick, that's fine as well. But go ahead and pause this, get these answers, and come back and check in a minute. Alright, here's number 1. It's perpendicular. And again, if you need to pause and check through my work to compare to your work, do so. Here's number 2. They're neither. Here's number 3. These are also neither. And number 4. These are perpendicular. So they didn't have parallel in these examples here for practice. Kind of wanted to see if you would try to guess one was parallel because you didn't see it popping up. So hopefully you didn't just put parallel because you didn't see it. Alright, so until next time, keep practicing.